machining can be a lot of fun, but there are ways to make it funner, faster, more efficient, and all around just better. Let me show you. For example, these parts we are currently running out of aluminum must maintain an almost perfect finish. So, we are using a Teflon rod as a stop rod with taped jaws and a plastic soft jaw. Not really sure what kind of plastic it is. It was just some black plastic we had laying around. It could be Teflon, could be nylon, could be Delrin. Really don't know. So I've taken one to the office so I can show you a little bit better. You can see there are small surface imperfections. Keep in mind I'm pretty zoomed in on this at the moment. But you can see that there's small surface imperfections. That's not so much of a problem because they do get anodized. However, anything that is a giant pit is going to be a problem. We have to avoid that. So you're probably thinking, Rogue, just get to the point already. Well, here's my point. We were trying to find a way to get chips to stay out of our end mill so it wouldn't gum up and, destroy itself. So we attempted an airline that was directed straight at it because coolant would make the tape come off. So we tried a coolant or an airline, was working, loud, making the compressor run all the time, and just less than perfect. So I got rid of that. Then I did something that most people would say is counterproductive. I increased the speed a ton. It's gonna get loud, headphone warning, blah blah blah. Let's go. Our oldest machine, which takes a while, but no coolant, no airflow, no nothing, just go. So looking out there, it's probably a little bit deceptive. So let's go over the numbers and I'll actually give you concrete speeds and feeds that we were using, or are using. Right now we are moving 120 inches a minute, 6,900 RPMs, because, funny number, 6.9, we're cutting width is 62 thou and a half per side. So that means my constant radial engagement is 62 and a half. And we're going 375 at once. Let's rip it up. This is also a volume mill path. So as you can see, it's doing some weird motions because what it's doing is it's constantly doing circles to attempt to stay in the cut as much as possible, all the way through this oddly strong shape here. So yeah, bottom line, if you're ever hitting a wall and you're not quite sure what to do, remember, tooling is replaceable. Your time is not.